Good morning. Welcome to 4.2. So this topic is on energy flow. So I'm just going to just say energy, NRG. It's just easier to write, don't do that on a test. Write it out completely on a test, okay? So I think a lot of this is review. So obviously the first source of energy is sunlight. Okay, so sunlight is the first source of energy. Well, we should say main source, right? Let's be technical here. Not everything needs sunlight. So I think I said in my last video, if I didn't, there's autotroph, and before autotroph you have photo or chemo. So that thermos bacillus bacteria that I keep talking about, thermos bacillus, evolution, genus, species, always, I write messy, but italics, right? Always write this stuff in italics. You can also write T dot bacillus. Okay, this is an example of a chemotroph, chemoautotroph, right? It's where attack and polymerase, it's where attack and PCR come from. So the main source of energy on planet Earth is sunlight. So sunlight goes to producers. So what we want to say, the key words here we want to use is light energy is converted into chemical energy. So light energy, this is photons in light, into chemical, which is glucose, right? So when we talk about like photosynthesis, I'm writing messy because I think most of the words you guys know. So photosynthesis, right? This is the conversion of inorganic, which is CO2, into organic compounds, which is glucose. Okay, don't know, I just did something weird there. Okay, so that's, not erase. Okay, so glucose. Okay, so energy is lost in this process. Okay, there's the basic 10% rule. So if you look at energy levels, so down here you have your producers, okay, and then you have your primary consumer. So in other terms, these are your plants, these are your herbivores, and then these are your carnivores or your omnivores. Okay, we don't put decomposers into this mix because they recycle things. So producers, consumers, secondary consumers. Okay, so 90% is lost as heat due to 9% is lost as heat during metabolic reactions. So every time we convert glucose, every time there's a chemical reaction in your body, we lose some energy as heat. That's it. This is it. 90% is lost when you go from producers to consumers and consumers to next level. This is why people say if you want to fight climate change, and people say be vegetarian, because if you're vegetarian, you're eating from the second, these are tropic levels. Sorry. This is your first tropic level. This is your second. This is your third. So look, we have the same name for the same thing. The first trophic level is the producers, is plants. The second trophic level is the primary consumer, which are herbivores. And the third trophic level is the secondary consumer, and the third, and the tertiary, and the quaternary. So same names for the exact same thing. So English loves this. English loves to have multiple names for the same thing. You have 10 different words for a sword, right? Okay, so same thing. Okay, so anyways, so if you go vegetarian, you're eating from the first level. Sorry, from the first level. So it's more efficient in terms of energy throughout the world. So this is why a lot of people say, if you want to fight climate change, go vegetarian. And there's a lot more. I can go on for that for hours and hours about climate change. And that's topic 4.4. So this is just energy flow. If I go, okay, so understandings is that most ecosystems rely on sunlight. So light is number one. That's the first thing. Light energy is converted into chemical. Okay? So, feeding. This is the term we use for food chains. Feeding is a relationship for how we explain food chains. So, food chains show the, the chemical energy flows through the food chain by feeding. So, animals feed on plants, other animals feed on other animals, chemical energy flows through there, energy is released as heat, energy is released as heat. Some energy, so now look, you have defecation, right? I'm getting lazy here. Okay, sorry. Defecation. So some is just lost because animals poop and urinate. So obviously some energy just lost as that. Some material is lost, it's broken down by decomposers and recycled. So this whole topic is simply just about energy lost as you go from up the energy pyramid. Energy is lost as heat. Because you're losing 90% of the energy, only 10%, that's why it's called 10% rule. 10% moves on. 90% is lost. So because we lose so much energy between trophic levels, this limits the length of a food chain. So food chains cannot get very long. They're much longer in the ocean where you can have small fish eat bigger fish, eat bigger fish. So in the ocean, you might have 6-7 steps, but on land, you only have 3 or 4 usually, right? So this keeps food chains short. So food chains are short. You need to understand how to use an energy pyramid. And so there's 3 kinds of pyramids. Okay. There is simply one based on numbers. There's a pyramid based on mass. And there's a pyramid that's based on energy. Energy is basically measured in joules. So it's basically energy per area per time. Energy, area, time. Joules, meter squared, year. Right? So and you can use, maybe better use kilometers, right? So let's say Vietnam. Vietnam is 1,000,000 kilometers big. Let's just say Vietnam, let's just say a country is 1,000,000 square kilometers. So how much energy is produced in this area given 1 month or a year? So this is the unit we use for pyramids of energy. Numbers is like, you have 1,000 trees, right? But see, here's the problem with numbers is why it's not covered in the syllabus, creates some problems. Because numbers, okay, you might have 1,000 trees, but you have like 1,000,000 insects, right? So you have a smaller number of trees and you have a huge number of insects. So your pyramid now looks like this. Like it looks lopsided. But if you take the mass of those 1 million insects, it's probably the mass of one tree. So you take the same numbers, apply it to the biomass, and the pyramid now looks like a pyramid again. Because 1,000 trees is way more mass than the 1 million insects. And then you have birds. So let's say we have trees, insects, birds, right? There's your energy pyramid. Okay? So that is in a nutshell. So numbers and mass are actually they're not in the syllabus. It actually says you don't need to know them. But if you start looking up energy pyramids and read about energy pyramids, they're usually going to talk about numbers and mass. So keep that in mind. They should always be drawn to scale. So in general, they're going to look like this, really large. I mean, actually maybe it might be more like this, right? Because 90% is lost and 10% moves on. Okay? All right. This kind of covers it for 4.2. It's really short. So I will put up questions for 4.1 and 4.2 today. Have a wonderful, wonderful day. Whoop.